Welcome back, everyone, to another deep dive into the world of AI with Artificial Intelligence, Unorthodox Lessons, where we break down those crucial practical AI topics. And of course, huge thanks to Notion Wave for sponsoring this deep dive, a leading AI company that's really making waves in research and education and beyond.
Glad to be here.
Today, we're diving into this idea that sometimes gets thrown around pretty casually in the world of machine learning.
Mm-hmm.
We need more data to build a better model.
Mm.
Sounds straightforward, right? Like more data equals better AI. That's always the answer.
Yeah.
But for those of you looking to really get a handle on this stuff quickly, our source material today is going to help us unpack why simply throwing more data at a problem isn't always the wisest strategy. It's not always the magic bullet. There's a lot more nuance to it.
Right. It's not quite as simple as that. It's
Right.
definitely more nuanced. And the source material we're looking at today really emphasizes that large-scale data collection, that's a major undertaking. It's not just about, hitting a button and suddenly having terabytes of data at your fingertips. It's a significant investment of time, resources, energy, and it really requires a very well-defined plan.
Definitely. And you want to make sure that it's actually going to pay off, right?
Exactly.
So before we even think about embarking on this huge data collection quest, the source highlights some really crucial questions to ask ourselves. For example, how confident are we that this new data, this mountain of data we're about to collect, will actually translate into a meaningful improvement in our model's performance?
Yeah, that's the core question, right?
Yeah.
Are we going to see a tangible benefit from all this effort? You don't want to go through all that trouble just to find out that your model is still stuck in the same performance rut.
And it's not just about whether it can improve, but also about the quality of the data, right?
Absolutely, yeah.
Are we going to end up with a bunch of noisy data that's inconsistent, or are we going to get, those golden nuggets of information that are really going to make a difference?
Yeah. And there's also the very practical consideration of like, okay, what if, even if we do manage to collect all this amazing data, what if our data science team just isn't ready to actually use it?
Right.
They might be swamped with other projects, or they might not have the right tools or infrastructure in place to handle this influx of new information.
And then it's just sitting there, right? Like a big pile of potential, but nothing happening.
Yeah, exactly. It's just sitting there gathering digital dust.
Okay, so the source is really making us think before we leap into this data collection frenzy. It's saying, look inward first at your current model's performance. Don't just assume more data is the answer. You need to have a really strong justification for it.
Yeah, you need to go beyond that gut feeling and really look at the evidence.
So maybe our model isn't performing as well as we'd hoped. Is it always because of a lack of data?
Well, not necessarily.
Yeah.
The source points out that there could be a whole bunch of underlying issues that more data just won't address. For example, you might be dealing with underfitting, which is kind of like your model is being lazy. It's not even trying hard enough to learn the patterns in your current data.
It's not putting in the effort.
Exactly. It needs to hit the gym. It needs to get those weights up. Adding more examples, it's not going to magically make it a more sophisticated learner.
Okay. Underfitting check. What else could be going on?
Right. You might also be running into what's called convergence issues, where your learning algorithm, the heart of your model, is struggling to find the best possible solution. Imagine trying to find, let's say, the lowest point in a valley, but you're blindfolded. Your steps are all over the place. And adding more ground to the valley, more data, isn't going to help you find that lowest point any faster. You need a better strategy for navigating the terrain, a better learning algorithm.
That's a really great analogy. Okay, so how do we figure out if our model is actually ready to benefit from more data? Is it going to be worth the time and effort? The source mentions this really intriguing bucket experiment.
Yeah, this is a clever one. So the bucket experiment is a way to kind of simulate the impact of adding more data, but using your existing data, which is pretty cool. You take your current data set and divide it into equal parts, like buckets, and then you train a series of models, starting with just one bucket, then two buckets, three buckets, and so on.
Okay, so we're basically seeing how the model performs as we gradually feed it more and more data.
Exactly.
Got it. And what are we looking for here?
So if you see a consistent improvement in your model's performance with each additional bucket of data, especially as you get to those last few buckets, that's a pretty strong indicator that having more data would likely be beneficial in the real world.
Okay, so consistent improvement, good sign.
Mm.
What if it starts to level off or, I don't know, bounce around a bit when we add those final buckets?
Right, so that's a really important signal. If adding more of your current data doesn't lead to clear-cut improvements, it could mean your model is approaching its limit with that type of information, or it might be starting to overfit.
Okay, overfitting, that's where the model basically memorizes the data instead of learning the underlying patterns, right?
Exactly, like that student who memorizes all the answers to the practice test but doesn't actually understand the concepts. They'll ace the practice test, but when they get to the real exam, they're lost.
Right. They haven't really learned anything.
Yeah, so in those cases, just piling on more of the same data might not be the solution you're looking for. However, as the source points out, even those performance fluctuations, where it's not a clear upward trend,
Yeah.
that could also suggest that while the immediate benefit isn't obvious, maybe a larger, more diverse data set could still help.
Interesting. So it's not a clear-cut yes or no in those situations. It's more like, more investigation needed.
Right, there's definitely room for more exploration there.
Okay, so let's say we've done our due diligence, we've run our experiments, and we've made a data-driven decision to collect more data. The source then shifts our attention to something that's just as critical: defining and measuring data quality right from the start. Why is this so important?
Well, because in machine learning, you really can't escape the garbage in, garbage out principle.
Right. It makes sense. If you feed your model a bunch of junk data, you're not going to get anything meaningful out of it.
Exactly. I mean, imagine spending all that time and effort collecting a massive amount of data only to realize that it's full of errors, inconsistencies, irrelevant information. It's a nightmare scenario for any data scientist.
Yeah, it's like building a house on a foundation of sand. So the source is saying before you even start collecting any data on a large scale, you need to define what quality actually means in the context of your specific data and your specific machine learning task.
Absolutely. You need to establish those clear parameters for what constitutes good data. And the source gives some really helpful examples. So if you're working with, let's say, an image recognition model, the quality of your labels, those little tags that tell the model what's in the image, is super important. Are the people doing the labeling? Are they properly trained? Are they being consistent? Or if you're collecting audio data, you need to think about things like acceptable levels of background noise. Is your recording equipment working correctly and consistently across all your data?
Okay, so we need these clear definitions, but we also need to be able to measure data quality at scale, right?
Absolutely. It's not enough to just have these vague notions of what good data looks like. You need to be able to quantify it, to measure it, ideally in an automated way.
I imagine that could be pretty challenging, especially when you're dealing with massive data sets. You can't just manually inspect everything.
Definitely. That's where things like data quality indices come in.
Can you give us some concrete examples of those in an AML context?
Sure. So a quantitative measure for, let's say, image data could be the resolution of your images. Are they all being captured at a consistent pixel density? For text data, you might look at the average length of sentences or the frequency of spelling errors. Those are things you can measure. On the qualitative side, for image data, you might look at things like lighting conditions. Are the images well lit and consistently exposed? Or if you're working with text, a qualitative note might be whether a particular source tends to use a lot of slang or informal language, which could influence how your model learns.
Those are really helpful examples. It shows how data quality is about way more than just whether the labels are correct. There are all these other factors to consider. But like you said, measuring all of this across huge data sets can be really tricky.
Yeah, it's a big challenge. And as the source points out, even our trusty data cleaning techniques like outlier detection, where we try to flag and remove those data points that seem way off, those have their limitations.
Oh, right, because sometimes those outliers might actually be valid data points.
Exactly. You don't want to throw away valuable information just because it looks a little bit different. It's about finding that balance between cleaning up your data and preserving those rare but potentially insightful observations.
Okay, so we've talked about justifying the need for more data, ensuring its quality, and the source brings up another potential pitfall: not clearly identifying all the data fields you're going to need right from the start. That sounds like a recipe for headaches down the road.
Yeah, it can be a really painful mistake. Imagine going through this whole elaborate data collection process, collecting all this data, processing it, cleaning it, and then realizing, oh, shoot, we forgot to collect this one crucial piece of information that would have made our model so much better. I mean, talk about frustrating.
It's that feeling of, I wish we had thought of this earlier.
Exactly.
So how do we avoid falling into that trap?
Well, the source really stresses the importance of planning, of thinking through your data needs very carefully up front. Of course, there's always going to be some uncertainty in the beginning. You might not know exactly what will be most useful. But the key is to learn and solidify those requirements as early as possible.
It's like building a house.
Yeah.
You
Yeah,
wouldn't start building without a blueprint, figuring out the rooms as you go along.
exactly. You need that solid foundation.
Yeah.
And the source strongly cautions against just collecting a ton of data now and figuring out what to do with it later.
Yeah.
I mean, that data might come in handy at some point, but the risk of missing those essential fields is just so high. You're much better off investing that time up front, being meticulous about your planning, clearly defining what you need to collect, and then going out and getting it.
Okay, so plan, plan, plan. That seems to be the recurring theme here. We've talked about justifying the need for more data, ensuring quality, identifying the right data fields,
Right.
and it all points to this need for really strategic thinking before we jump headfirst into a massive data collection effort. And that brings us to the final key takeaway from the source, which is the value of an iterative approach.
Yeah, this is all about not putting all your eggs in one basket. The source suggests that instead of going for one huge data collection push, we should think about it more as a cycle. Collect some data, analyze it, learn from it.
Kind of like a feedback loop, right?
Exactly. So you collect that initial batch, you look at it, you figure out what worked well, what didn't, what's missing, and then you refine your strategy for the next round of collection.
It makes a lot of sense. It allows you to uncover those unknowns, those things you didn't anticipate, and adapt your plan as you go.
Yeah, it's about being flexible, being responsive to what you're learning, and it also allows you to address those data quality issues we talked about earlier. If you're seeing consistent problems with a particular data source, you can adjust your approach.
So it's not just about collecting more data, but about collecting smarter data.
Exactly. And the source wraps up with a really crucial reminder, which is that more data isn't a magic solution. It's not going to solve all your problems. If your underlying model is flawed or the features you're using aren't informative, even mountains of beautifully collected, high-quality data isn't going to get you the results you're hoping for.
Right. It's like trying to bake a cake with a broken oven.
Yeah.
You can have the finest ingredients, the perfect recipe, but if the oven's not working, you're not going to get a cake.
Precisely.
Okay, so to bring it all back to that initial statement, we need more data to build a better machine learning model. It's not always true, and even when it is, it requires careful planning, a strategic approach, and a constant willingness to learn and adapt.
I think that's a great summary. More data can be incredibly valuable, but it's not a shortcut to success.
So to recap our deep dive into strategic data collection, number one, make sure you're actually justified in collecting more data. Analyze your model's current performance. Try something like that bucket experiment. Make sure it's actually ready to benefit. Number two, define and measure data quality right from the start. Avoid that garbage in, garbage out trap. Number three, plan, plan, plan. Think through all those necessary data fields. Don't leave anything to chance. And number four, remember the power of an iterative approach. Collect, learn, adapt, repeat.
Couldn't have said it better myself. By taking that strategic approach, you can really set your AI project up for success.
We hope this deep dive is giving you some food for thought as you navigate the world of large-scale data collection in AI. And for more essential and practical topics in AI, be sure to follow our podcast, Artificial Intelligence, Unorthodox Lessons, wherever you get your podcasts. We'll see you on our next deep dive.